Now we will see the simple construction of static switch. Okay, we know thyristor or silicon controlled rectifier was a great invention. We can control the flow of current. Okay, when to start it, we know that. Now here, normally supply will be through inverter. If inverter is working fine, and it will go to UPS output. This thyristors or SCRs will be fired. Alternating cycle, we know that. Okay, so power supply will be through this inverter. Now if this fails, okay, there is a programming to switch this. Okay, then these SCRs will be switched, and here no power, so those will be switched off. So this will be blocking and this will be conducting. See, the UPS continuously powers the load through inverter path during normal condition. Okay. Then the bypass path SCRs are in blocking state. The bypass path, those are in blocking state. There will be no pulse for their gate. Gate will not be open. Now, if a fault or overload occurs in the inverter, then what happens? Or UPS enters maintenance mode automatically. If UPS is not working properly, then the bypass SCRs are fired. Those will start conducting, transferring load to bypass supply within 2 to 4 milliseconds. This is very fast. 2 to 4 milliseconds. In one full cycle, it takes 20 milliseconds. In half cycle, 10 milliseconds, and quarter cycle, 5 milliseconds, and half of that, 2 to 4 milliseconds. Half of quarter cycle. This deviation, your IT loads will not come to know. Okay. If you are catering to very critical loads like operation theaters of hospitals and data centers, in that case always use n plus n or n plus 1 redundancy UPS. Then this thing will not come into picture. If one UPS fails or inverter of one UPS fails, second will automatically take the load. There will not be any switching. Okay. So it is standby, always ready to take the load, or load sharing will be there. Now, if in case it goes on bypass, still the IT load will not come to know, because it is happening in very less time, 2 to 4 milliseconds, fast enough that IT or critical loads never drop out. Okay. Why back-to-back SCRs are used? AC current alternates direction every 10 millisecond. 10 millisecond half cycle, 10 millisecond. That is why for back and forth, those two SCRs are used. Now, see, two SCRs in anti-parallel handle both half cycles. When triggered, they effectively act like as a bidirectional electronic switch. Okay, this configuration is more reliable than mechanical relays because switching time is less than 4 milliseconds. No mechanical wear can handle large surge current. It can handle large surge current. That is why this is used, SCRs. Operation and purpose. The static bypass consists of solid state switching devices, typically SCRs or thyristors, that can transfer the load from inverter to utility power in 2 to 4 milliseconds, fast enough for modern equipment. Tolerate this brief interruption. Static distinguishes this electronic switch from mechanical maintenance bypass switch, emphasizes the absence of moving parts, and the result is fast operation. So in this way we know how STS works. Okay.